All right, this is going to be a couple of Taguchi loss function problems out of chapter 17. So the first one is 17-43 that we're going to look at, and we've got the desired distance on a Flexor chip customers is zero point 0.2 millimeters between two adjacent pins. Any deviation from this value causes interference. The process of handling complaints costs the firm about $40 per chip. The engineers of the firm expect the average customer will be likely to complain when the distance is off by at least 0.0001 millimeters. So three zeros and a one. At the factory, the adjustment can be made at a cost of $1.60, which includes the labor to make the adjustment and the additional testing. So what is the value of the cost coefficient? So number one, we need the cost coefficient, and the formula is the total quality costs, which was given to us at 40, equals K, which is the value that we are looking to find, times the tolerance squared. Okay. And so we plug in the numbers. We've got 40 here, and we've got the tolerance squared is 0.0001. Okay. And so now we just use a little algebra, get that over there, and so K equals 40 divided by 0.0001 squared. And when we work that out, starting at the 0.0001, so squared is 0.000001, so 7 zeros and a 1, and then we have 40 that we divide by that will give us 4 billion. All right. Now that remember that cost function is the cost for a tolerance off by 1, and this is 0.0001, and so this number is going to be large compared to our loss, but that's the answer for number 1. And then number 2 says based on the Taguchi loss function, what should be the tolerance before an adjustment is made. So now on this one, we want the $1.60, right, to be given to that's given to us equals the 4 billion, the K, divided by the tolerance squared. All right, so we get so yeah, so we get the $1.60 divided by the 4 billion equals the tolerance squared. So $1.60 divided by 4 billion is a very, very small number, but then we take the square root of that, and we get .00002. And so the specification should be 0.2 plus that, so 0.20002, or 0.2 minus that, which would be 19998. So this is part 3. All right, so that's the first one that we're looking at. Then we're going to look at number 17-44. And we've got Duramold specializes in manufacturing molded plastic panels to be fitted on car doors. The blueprint specifications for the thickness of a high demand model calls for 0.1875 plus or minus 0.0025 of an inch. It costs $120 to manufacture and $150 to scrap a part that does not meet specifications. Okay, so we want to do what is the estimated cost coefficient. So we go back to our formula before, the total cost equals K, what we're trying to find, times the tolerance squared. Okay. And so we know that the total cost in this case is $150. That's given to us in the problem, equals K times tolerance squared. So K is going to be 150 divided by the tolerance squared. And the tolerance squared is 0.0025, right? Yeah, 0.0025. And we square that is 0.00006. And then we divide 150 by that equals 24 million. All right, so that's part 1A. And then part 1B is to estimate the loss when we have 0.18, when we have a panel that is 0.1893. So what we need to do there is take that minus the standard, which is 0.1875. Equals 0.0018. Okay, and then we will square that. And so we've got the 24 million times 0.0018 squared times 24 million equals $77.76. Okay, so that's 1B on that. And then part 2 says, assume Duramold can eliminate the uneven thickness by adding a production worker at the critical production point for $6 a unit. Under this assumption, at what tolerance to 6 decimal places should the panels be manufactured? And for this calculation, the total quality cost is equal to the above $6 unit. So they're telling us that. So in 2A, we're going to have $6 equals 24 million times the tolerance squared. Okay. And so we get $6 divided by 24 million equals the tolerance squared. And we need to take the square root of that. Equals 0.0005 on that. And so now that's what our tolerance should be on this. And so part 2B, what should be the production specification for the panels? And so now we have 1.1875 plus or minus 0.0005 is going to give us 0.1880 on the high end, 0.1870 on the low end. And that is part 2B on that. All right. Well, that's it for that question. And so that's the Taguchi loss function. Not going to see a whole lot on your test on that.